Welcome to this video about artificial intelligence in SAP IBP from my supply chain group. My name is Alexander Vonk, and on the video connection I also have Mahesh Latkar. Mahesh, can you introduce yourself please?
Hello, this is Mahesh Latkar from my supply chain group. I am SAP IBP SME.
Thank you. So today we would like to discuss demand planning and demand sensing for AI. But first we'll basically define a little bit further of what we mean with the demand planning and demand sensing in the IBP context of SAP. And then we'll deep dive into using AI for demand planning and for demand sensing, and then we'll close with a summary. So demand planning and demand sensing are two different aspects of the SAP IBP system. Mahesh, could you explain a little bit further?
Yeah, sure. Demand planning is typically a conventional method of generating statistical forecast based on the sales history or shipment history. And we can generate forecast for long-term horizon for 18 months to 24 months. And with a demand planner override or many other inputs like sales and marketing forecast or customer forecast, we can influence the demand planning output in terms of consensus forecast. That output can be used for supply planning, and also it can be used in demand sensing. On the other hand, demand sensing, it's a shorter horizon. So we'll talk about here daily buckets, and the horizon could be for 4 to 6 weeks. And the output of the demand sensing will be in daily buckets, though we can view it at weekly buckets at aggregated level. In demand sensing, it uses the recent sales data or sales history, and also open sales in near future and actual shipment data, and it gives the output based on this all inputs.
So demand planning using AI, can you elaborate on what kind of AI can be used for demand planning within SAP IBP?
Sure. So here we're going to use 3 forecast models, which are based on machine learning, multilinear regression model, auto Aremax and Sarimax, and third one is gradient boosting of decision trees. So here we'll be using the same input in our example, sales price, for example. You can also have other parameters like weather forecast or temperature housing index as part of this input to these AI algorithms. And in this video, we'll try to focus on gradient boosting of decision trees.
So how do these AI algorithms help you creating a better demand planning forecast compared to, say, traditional mechanism of something like exponential smoothing or an ARIMA model?
Right. So very purpose of using artificial intelligence in a planning process is to read the pattern based on your history and apply that pattern for your future demand. That's what we're going to see in further slides.
Okay, excellent. So here we see an overview of the various kind of charts that you can get as a result of applying artificial intelligence for demand planning. Mahesh, can you explain what we are seeing here?
Sure. So these charts represent 3 forecast models, what we're trying to use in this video. Here you can see on top chart, there's the sales price, which is the input, and actual quantity adjustment, which is your historical data. And in this particular case, it will try to read your sales price and actual sales. It has got some correlation. And once it is the pattern, it will apply for the future forecast. So on the top chart, we are trying to show ex post forecast for all of these forecast models based on machine learning, MLR, gradient boosting, and Aremax. So here, the important thing is to understand, if you look at gradient boosting output, which is a red line. So wherever there is a less sales price, you will see there are high numbers or high quantity of forecast generated. And wherever you got high price, it is that forecast numbers are coming down. So that's the purpose of AI algorithms to get such kind of output. Okay, this next chart is talking about the comparison between gradient boosting versus MLR. And if you look at the orange line, it's a sales price. It's quite fluctuating. And if you look at this, the gradient boosting output, the forecast, the way it generated, you got wherever you got less price, sales price, you have high forecast. So this is for the future horizon for maybe next 24 months. The third chart is talking about the comparison amongst these three of the AI models. Here also we got input as sales price, and this is all in monthly bucket. And if you focus on this black line, which is gradient boosting forecast, so you get a similar kind of results. So you have less sales price and high forecast numbers compared to other models. If you look at green or pink line, those are Arimax and MLR. So those are more linear in nature. But if you look at gradient boosting, it is reacting to your sales price. So that's the reason we'll be more focusing on gradient boosting.
Wow, that is fascinating. Would it be possible to show this in Excel of what it looks like?
Sure. Okay, so we'll be first talking about ex-post forecast, how it is generated. So here you can see our planning level is product location customer. We are trying to view this data at this planning level in monthly buckets. You can also view this data in weekly buckets because data is getting stored in weekly, and you can always aggregate at monthly level. So in this particular example for this gradient boosting, here we got sales price as an input and actual sales for the past 1 year. So here the way we maintain this data, wherever you got less price, you got more sales. Okay, so system has to read this pattern and come up with the numbers, forecast numbers. So if you look at this output of this algorithms, so we got MLR, multilinear regression, we got ex-post forecast for gradient boosting, and ex-post forecast for Arimax. And this ex-post forecast quantity, this is the final result of this output. So it will choose based off these three models. Okay, if you can see here, it has chosen gradient boosting as the best fit for this particular example, because the reason is that it is applying the same pattern. If you got the here high sales price, your forecast number is coming down, and where you got less sales price, your forecast number is going high. Similarly, here you got $50 sales price and the number is very high. So if you look at this pattern, it is really reacting to a sales price. And next we'll talk about this forecast. So this is for future horizon, maybe next 1 year. And here we maintain also sales price for the future horizon. And the statistical forecast quantity, this is your final output, and this is the forecast quantities. We also had these three models, forecast models, and you can look at the result for the forecast quantities. So here also it has chosen this gradient boosting forecast as the best fit. Yep. The reason being the same thing, right? So it has got a sales price, less sales price, and high numbers. And wherever you got more sales price, the sales is forecast is coming down. So that's the reason it has chosen the best fit. And the third tab is, so data is stored in the weekly buckets in calendar weeks or technical weeks. You can always aggregate at monthly level or quarterly level, but here this data is stored like this in weekly buckets.
Okay, very good. That was a good demonstration of demand planning using AI. Now, we also have demand sensing using AI. Mahesh, could you explain how that works with demand sensing using AI?
Sure. So earlier we discussed about gradient boosting, demand planning using AI. And there we had different types of forecast models. And the lowest bucket was time bucket was weekly, technical weeks. But here we are talking about daily buckets. So it can read data in daily buckets, and also it can give the output in daily buckets. So that's why it's very important. In demand sensing algorithm, this is based on machine learning, and it is the IBP standard algorithm. It also recognizes the pattern from daily or weekly buckets from your recent sales and deliveries. And also you can have downstream signals and you can apply that logic to this AI algorithm. This demand sensing algorithm, it influences the sense demand based on downstream signals like customer point of sales or customer inventory that we can model. So we'll talk about one of the scenario for customer point of sales in coming slides.
Okay, very good. So the demand sensing process is highlighted here. Mahesh, could you walk us through this particular outlay?
Sure. So this left part of the slide is all inputs going into demand sensing. So consensus demand, which is the output from the demand planning, right? It's in weekly buckets. Then you got historical sales orders and future open orders, historical shipments or deliveries. You can also use promotion data here at a product location customer level. And also you got downstream signals. So in this example, we'll be using point of sales, customer point of sales. We can also apply store inventory, customer store inventory, and other many inputs. As part of pre-processing, we got two options here. You can also use product lifecycle planning as part of demand sensing for new products, and also promotion elimination algorithm. This algorithm will eliminate the promotion data from the sales history, and it will smoothen that history so that we can use it for demand sensing output. Next is machine learning and pattern recognition, which is very important. So demand sensing reads pattern in daily as well as weekly buckets. It also does forecast consumption as part of demand sensing. You can always switch off this forecast consumption if you're using any time series algorithm for the planning. There you can apply the forecast consumption. Output of demand sensing is in daily buckets. Data is stored in daily buckets, but you can always view at weekly level.
Very good. So we talk a little bit more about that in the next slide. So can you walk us through this, please, Mahesh?
Here, important part is Massair types. So if you look at the screen, we are using sales order, Massair type, deliveries, and this can be used in time series as well, because these attributes are defined as attribute as key figure. You might have multiple sales order on a single day or multiple deliveries on a single day. Then you can view this in the planning view at aggregated level. So it will sum up all your sales order quantities and delivery quantities, and it can show you on a daily basis. Next is promotion Massair type. If you are using promotion as part of demand sensing to eliminate the promotion quantity from the sales order, that we can use that.
This is a slide that describes some of the outputs that you can get in chart format. Mahesh, could you walk us through these charts?
Yes, so here we got three charts. The first one is here we're trying to show delivered quantity in the past and requested quantity, which is nothing but your sales. So it can be your sales history, and it is your open sales in future. So system will try to correlate this data with this requested quantity and delivered quantity. It will read the pattern, and it will try to apply this pattern for the near forecast, near future forecast. In this case, if you can see, we got two key figures, demand planning quantity, which is coming from the IBP demand planning or any other demand planning tool. And green is demand planning quantity, which is showing the lower forecast quantities compared to the sense demand, which is the pink line. So
the sense demand is,
yes.
Sorry, the sense demand is the output, right, of the algorithm.
Sense demand is the output, yes. And if you look at this requested quantity and your delivery quantity pattern, it is very well reacting to these inputs. So next chart is it's talking about snapshot for demand sensing versus demand planning. So you can have a snapshot for maybe past 52 weeks stored in your system coming from demand planning. And you can also generate snapshot for sense demand using standard algorithms. So here, if you look at the pattern, the way it had generated forecast, so sense demand is in green line, which is very close to your open sales quantities. And if you look at the forecast demand planning quantities snapshot, it is very, very high, because it's a conventional method of generating statistical forecast based on your shipment data or sales data. So demand sensing is very useful for near term, and you can make a lot of decision based on this input. The third one is combined final demand, which is one of the standard key figure. Here we are trying to show this sense demand and demand planning quantity. So sense demand is in blue bars and demand planning quantity is in orange bars. So if you look at this near-term data, it is picking up this from sense demand quantity for first 4 to 6 weeks as part of combined final demand. And for the future, it is getting the quantities from demand planning quantity, which is your IBP demand planning results. So it is combining both of the results in one key figure. And this is the final output from demand sensing, which can be used further in inventory optimization or supply planning.
Very good. So would it be possible to show this in Excel, Mahesh?
Sure. So here we'll be talking about customer point of sales. If you can look at this planning view, this is showing product location and customer planning level. This is in weekly buckets, though data is stored in daily buckets. Requested quantity is one of the main input for demand sensing. Also, you have a delivered quantity, shipment quantity for the past buckets. And additionally, we are giving this customer store point of sales input to this algorithm, which is one of the downstream signals. You also have demand planning quantity, which is coming from IBP demand plan in weekly buckets. And then output would be your sales demand quantity final and combined final demand. So here we're just putting a few time buckets here, 10 or 12 time buckets. So current week is calendar week 18. So you will see demand sensing output will be from the current and future buckets for next, I think, 6 buckets. Here we got customer point of sales, additional input. So you need to maintain enough data in the system, maybe up to 52 weeks at least, so that system should be able to learn the pattern. Okay, and all these downstream signals, in this case customer point of sales, it will try to relate to the requested quantity in the past, and it will form some kind of pattern, and it will try to apply that pattern for the future forecast, okay, which is a demand sense quantity for the future buckets. Here we can do the simulation. For that, I need to select my scenario, what I created already, which is customer point of sales. So this is my customer point of sales, and what I'll do, I'll remove these quantities from here, and we will see by doing simulation how it impacts the demand sensing output. Okay, so there are slight changes in this forecast final output. So if you look at these numbers here, so this is your demand planning quantity, which is in weekly buckets coming from demand planning, and this is your sense demand. Okay, final sense demand. If you look at this number, there is a big difference. So these are at lower side and it's being very high in this week. If you look at this 199 versus 286, then here, so it is picking up the pattern and it is respecting your open sales requested quantity as well. So what it does that it reads this requested quantity in future, and also it tries to read the pattern from the past and compares with this downstream signal customer point of sales with requested quantity and come up with this number. So if you take a total, for example, it's 1659 for these few buckets, and it is giving output is 1714, which is a little higher because of your open sales in near future, and you can also expect some more demand. If I refresh the screen now, we'll go back to the base scenario, and if you look at now total here, it's 1733. Yeah.
So this is still a little bit higher because there's actual recorded customer sales, store sales, which basically looks higher than
Yes,
the sense demand before.
right. So if I try to increase this number here now from 1000, I'm saying that okay, my sale was very high for this weeks. Then I'll do simulation again. So this time number should go further high. It is now 1764, which is higher than the previous result. So that's how it will react to your downstream signals, and as well as requested open sales or requested quantity in the past.
So it will use the store sales as a signal, but it doesn't do that in an outsized way because those numbers were really high, right?
Right, yeah. So as I said earlier, we need to maintain this data at least for 52 weeks. And if you got enough data and good quality data, it will give you good output.
Excellent. Yeah, that drives the point home well.
Yeah, and this is in weekly buckets. You can also view this data in daily buckets because this data is stored in daily time buckets. So here I created one planning view. You can also see these numbers in daily buckets.
Yeah, so is there anything special to mention about the daily buckets compared to the weekly?
Yes, so here we can maintain data, maybe the way we maintain it, it will react to that. So for example, if you are maybe making shipments on a particular day or every Monday or Wednesday, right, in that week, then it will try to respect that one if you got the similar data in the past. So it will try to read that pattern that you are making a lot of shipments on Monday or Wednesday, then it will try to generate more numbers on that day. Maybe one DC versus other DC. So one DC operates, distribution center operates different way. Maybe Wednesday is very peak time, and for other DC, maybe Friday is peak time. So that way it can split those quantities. Yeah, so there is a lot of flexibility and a lot of inputs you can use further to this customer point of sales. You can also use customer store inventory, or you can use promotion data or actual promotion impact. These kind of signals you can use.
Thank you, Mahesh. That basically drove the demand sensing using AI very well. So in summary, basically, we demonstrated how you can use demand planning using AI, and you can the AI part basically allows you to use other kind of data that are not related to the quantity-based time series, like for example sales price, to improve your statistical forecast and improve the quality of demand planning that way. We also showed how you can use demand sensing with AI and include other kind of data there, like point of sales or stock data, to improve your nearby demand picture. Mahesh, I would like to ask you some more questions on this. So we talked about demand planning using AI and demand sensing using AI. Are there any other aspects of the SAP IBP system that use artificial intelligence?
Yes, so I can say about gradient boosting. Output of gradient boosting can be used in demand sensing. So both are machine learning algorithms. One is at weekly level, other is at daily level. In other terms, so AI we try to show for only demand planning here and or demand data. It can be also applied to supply using artificial intelligence. I think SAP talked about this a few months back, that they are going to come up with some solution for supply planning using AI. It is not on the roadmap yet. Maybe it can maybe come in near future or in 1 or 2 years. But I would like to tell you, my supply chain group already started working on this for supply planning using AI. And the idea behind is we can use the output from supply planning. It could be supply heuristic or optimizer, and that output can be fed into AI engine, and it will suggest a few quantities based on your output from the supply. And this output of AI can be again fed back into your supply planning for the planning.
Yeah. Okay. And so given the COVID-19 situation, or is there also some way that we can use AI to help with situations like that or other kind of natural disasters?
Yes, absolutely. So very purpose of demand sensing is to react to this recent data, right? Recent history and your open sales in near future. So with the COVID or any other natural disaster, right? If your demand is coming down, then demand sensing will very well react to that your demand and also recent history.
Yeah. Excellent, very good. So if you would like to know anything more about how you can use artificial intelligence for SAP IBP or have any other kind of questions, please contact Suraj at the email address or telephone number that's on the screen. Well, thank you, Mahesh, for your demonstration and all your explanation. And thanks to you, the audience, for watching this video, and hopefully we see each other in the future.
Thank you, Alexander.